we're going to talk about linearity and symmetry. Linearity. So we'll do linearity first. In other words, what makes an equation a line?
It is linear.
Okay. So it needs a slope. You're exactly right. Thank you. It does need a slope. What else does it need? Like what? How do you look at an equation and determine if it's a linear?
Points.
Yeah, only need the slope really.
Let me give you a couple of equations, and you tell me linear or not, and justify why.
If it doesn't have a...
Not linear. Linear.
Yeah, that's linear.
Definitely linear. This one, it does have a slope, but you'd have to rewrite it. The equation, the form of this equation.
It's already in the standard form. So you don't need to. You have the intercepts right there.
That's right. And right now I'm just asking you yes or no, is it a line? Here's the thing, if you can write it in any of the forms that we have talked about of a line, then it's linear. If it's y equals a number or x equals a number, those are both linear equations. They both form a line. Point slope.
It's y minus y1 equals m times x minus x.
If it can be written in any of those forms, then absolutely yes, it is a line. Let me show you another one. This time I'm going to tell you it's a function. Linear or nah? No, I can't have an exponent. None of these equations have an exponent on x. So no, that is not a linear function. Do you see where we're going with this?
But like the parabola or whatever, it forms a line.
No, it forms a parabola, but not a line. Lines aren't curved.
But it'd be curving though.
Lines can't ever curve.
But the line be curving though.
Watch this.
That's a line.
Curve.
That's a line.
Linear or nah?
You can't write a function as a thing.
Yeah, not.
Linear.
Yes.
So you can write that in slope-intercept form. Do it.
No, I ain't do that.
If you multiply x.
Even if I can, I'm not.
Okay, so Dylan says if you multiply x, what are you multiplying x? So you're going to multiply it both sides?
Basically 5 over 6.
It's 5 over 6.
It's basically 5 over x. What?
It's not, so it's basically 5 over 6x, like 5, 6x. That's like a slope.
So I can rewrite it this way.
Yeah.
I can get x out of the bottom of that fraction, in other words.
I think so, actually. I think what you do is you erase it and move it to the top. It works.
You just hit the erase button.
This is non-linear.
Is there an easier way to figure out if it's linear?
Okay.
Because, like, if I was on my test, I would honestly feel like if I was...
That one's a little bit harder. That one looks like this. If x is ever in the denominator, it's never going to be linear. Okay, so just remember that. If x has exponents or it's in the denominator, then it's not linear.
So is that basically what the whole lesson is
No.
about?
All right, so a big part of today's lesson is talking about the symmetry of graphs, okay? And it's pretty easy whenever I show you the visual that I have to actually understand the symmetry. And we're going to get to where we do like a 10-point analysis on graphs, maybe even more. And this is just one of those points of analysis that we'll do for that graph. It'll be lots of fun. Y'all get excited. But one of those is looking at the symmetry of graphs. And normally I do this lesson with the next lesson. That's why it's not. Y'all were talking about we didn't have time, but we'll just do one instead of two today. Yeah, like 11:25. We got like 15 minutes.
We really have 5.
All right, so we got two types of symmetry. We have what we call line symmetry, which is probably the thing that you are most familiar with. It means if you draw a line and cut the graph in half, it's the same on either side. Okay. Like a what? Like a heart. Okay. Yes. Yes. A heart would have line symmetry because, yes, but we're going to be talking about functions that we graph. So we're going to be talking about things like parabolas have line symmetry.
Yeah. Wow. That's a whole lot.
You can do it from the line too, right?
If it's a certain way you can, but not always. How about this, by the way, is what we call a quartic.
Yeah, that's a
Yes, it has line symmetry straight down the middle. I can cut it. It's the same on either side. Is that pretty easy for everybody to understand? Let me show you. It's also called reflectional symmetry because it reflects about a certain line. See how this one, if you reflect it? So what this is doing is this is taking either side down this line and it's flipping it over and it's lining back up on itself. That is patty paper. Yeah, no patty paper here. We'll just use Desmos. Yeah. All right. Does that make sense?
Wait, let it keep blank.
Okay, it's never going to stop.
It's amusing, yeah.
It's an infinite loop. All right, the other type of symmetry that is probably the most confusing for students is point symmetry. Sometimes this is also called
I think a dot is very symmetrical.
rotational symmetry. Because if you can rotate the graph about a point
Oh, that's where the patty paper came in.
and
Right
it
there.
maps back onto itself, then it has rotational symmetry. In other words,
You mean rotational?
No.
I don't think she ever said before.
that's another name for it, is reflective symmetry.
Oh,
It's
for
just another
line
name.
symmetry?
Yeah, yeah. Because it's reflected over a line. If I looked at this cubic graph, I can't cut it in half anywhere unless it's like a diagonal line. We're not talking about like diagonal. We're talking about horizontal or vertical line. But I could take this and just turn it upside down, rotate it 180 degrees, and it maps back onto itself, right? So it has what we call point symmetry. Let me show you what that looks like because this one's really cool.
Wow. Wait, that's rotational. Wait, that's what
Rotational and point symmetry is the same
Oh,
thing.
yeah.
See how it maps around back at 180 degrees? Okay. It's a lot easier to see visually to understand it whenever you see it visually this way. Does that make sense to everybody? Y'all sure? What type of symmetry?
That right there is definitely rotational.
Reflective.
Raise your hand if you think it's reflectional. Which is line symmetry. Raise your hand if you think it's rotational.
Because there's a bottom and a top on the right and left side. It's rotational.
It's rotational.
Like on the right side it goes up and on the left side it goes down. Right there.
It is rotational, by the way. If we're going about the origin, it's rotational.
And this one we do is rotational.
Neither. You're right. Neither. The humps aren't the same. You see it? This is another Desmos that I really like to do with y'all whenever I introduce this section, but we were behind from our Desmos yesterday. How about this one? Line reflectional, absolutely. You're getting the hang of it, right? Okay. Now we get to the sketch part.
Annoying. That's rotational.
We always say rotational.
That's still rotational. No, it's reflection. No, it's
It's
neither.
reflection.
It's neither.
It's a reflection.
Why?
Because it's a I remember Miss Wilson said something that's reflection.
It's reflecting over the x-axis this time.
I was gonna say.
No, I couldn't see the bottom.
That's correct. I thought it was gonna really like animate them again, but I guess it only animates the first one. All right, that's all I got for you.